Physics 2 Lab 1, the analysis of charged tapes repelling each other. All right, so table of contents, there's introduction, data and observations, code, discussion, and conclusion. So for the introduction, the purpose and fundamental principles here, the main purpose of this lab is to observe how neutral objects can hold charges and interact with each other. It demonstrates Coulomb's law of electric charge, attraction, and repulsion, and Newton's second law needs to be considered for the influence of gravity on the system. And for a preview of the results, the positive charges that the tape hold causes them to repel each other. Newton's second law, known as the momentum principle, states that a force is equal to the change of momentum over the change in time. It indicates the changes of movement within the system and the surroundings, and this needs to be considered for gravity on the tape. Coulomb's law states that the magnitudes of charges influence the repulsion or attractive ability of the charges, depending on the magnitude of the distance between the charges. So for the experimental model, the top tape was considered to be the system and the bottom tape was the surroundings. The tape mass was found to be 1.02 times 10 to the negative 4 grams. Length was 0.15 meters and width was 0.02 meters. The tape was distanced about 0.033 meters away from each other and showed slight repulsion. So as far as the code goes, in order to find the charge of the single tape, you had to define the electric field, and doing this by distance, and then finding how powerful the electric field needed to be to repel gravity. So you had to calculate for gravity using mass times the gravity constant of negative 9.8. Then you take that absolute value to find the electric force, and then using the electric force, you can then put that into the Coulomb's law equation in order to find what the charge would look like. And the electric field on one piece of tape was found to be 1.09 times 10 to the negative 8 newtons per coulomb. So that was modeling of point charge. So in order to actually model the code to make it a little bit more accurate to what the tape would look like, you had to do it with multiple point charges right next to each other in order to do a line of charges, which is similar to how the neutral object of the tape holds the charges in real life. So similarly, you would calculate electric field by using the distance equation, finding the magnitude of the distance between the two charges, then finding their direction and calculating for electric field using the Coulomb's law equation. Then you would need to find line charges, and the charges are all just pretty much equal, but across the piece of tape that was modeled below. And then additionally, you had to create the actual model for arrows representing the forces of gravity and electricity, and also the top line of cyan circles being all the charges representing the top tape being repelled, while the surroundings, or the bottom piece of tape, are the orange point charges that act upon the cyan charges. And that way the charges can be observed influencing every single part of the tape and not just a point charge. So for the results, the magnitude of electric force was found to be 8.91 times 10 to the negative 6 newtons, and the magnitude of gravitational force was 9.996 times 10 to the negative 4th newtons. As far as sources of errors go, the tape was not in a controlled environment and could have lost charge due to interaction with the surroundings, which is why it was important to handle the tape in a very certain way so that way it wouldn't discharge. So for what if the protons became negative and electrons were positive, the observations would not change. The tapes would still repel each other because of the presence of like charges. Negative and negative and positive would do the same thing. The negatively charged protons would just have been lost instead of the negatively charged electrons. And why is it important to handle the tapes as little as possible? This is because it helps to avoid discharge of the electricity that would be present on the neutral objects. Because if they interact too much with the surroundings, they can discharge and they would lose their charges and not be able to repel each other anymore or exhibit repulsion of like charges. Thank you.